Hello, my name is Jim Broach. I'm the director of the Penn State Hershey Institute for Personalized Medicine. And I'd like to welcome you. We inaugurated the Institute in January of this year with the goal of bringing all the tools of molecular biology and genomics to bear on patient disease onset and on the response of patients to various disease treatments. I'd like to take you on a tour of the Institute. I want to show you the biorepository where we store our samples, the Genomics Center where we do the analysis of these samples, and the Bioinformatics Core in which we correlate the information that we get from the genomics with the patient records that we gather from the electronic medical records. So come this way. So the first step in the process is consenting patients, collecting and preparing samples.
To make personalized medicine work, we need you to donate samples. This is a completely voluntary process where we'll ask for blood, saliva, or samples left over from procedures. After you've consented with us, that means give us permission to use your samples and your information, we will store your samples and your health information indefinitely. None of your personalized information will be on the tube.
A critical core facility within the Institute is the biorepository.
After blood is processed into storage tubes, it is placed into long-term storage in secure freezers. Samples are barcode labeled, placed in storage boxes, and frozen in ultra-low temperature freezers until analysis.
The first step in the genomic processing is to extract DNA from each of the blood samples.
This is the QIAsymphony DNA extraction robot. It uses magnetic bead technology to isolate DNA from samples such as saliva and whole blood. It's a high throughput system that allows us to process large numbers of samples, up to 96 at one time, giving us high quality results in a short period of time. We load samples and reagent kit into the machine. The robot takes over, moving the sample from place to place through the process, depositing DNA into tubes at the end of the run. At this point, we can remove the tubes, the DNA, and use them for further processing or put them in the freezer for long-term storage.
Having extracted the DNA, we now need to fragment the DNA to prepare it for its genomic analysis.
So at this point, we take the extracted DNA and put it into this machine where we use focused sound waves to shear the DNA into smaller pieces. We need to take it into the smaller pieces so we can move into the next step where we can efficiently make a library of the DNA so we can move it into the next generation sequencing.
Now if you'll follow me, we'll walk over to the Genomics Core. A second critical facility within the Institute is the Genomics Core.
We then take that isolated DNA and here in Genome Sciences prepare that DNA for genome sequencing. Using state-of-the-art technology like this flow cell, we can then sequence the entire 3 billion bases of a human genome.
I hope you've enjoyed your tour. As you can see from the resources that we have at the Institute, we can obtain a detailed portrait of each and every patient. Feel free to explore additional information on our websites. That's www.med.psu.edu/IPM. Thank you for your time.